The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We will be doing our 30-minute free training session today for SolidCAM Live. With me, as always, is Kevin Rankle. Hey, Kevin.
Hey, how's it going?
So today, we'll be doing thread milling. It's a topic that we don't cover a lot. A lot of customers don't really use it, but when it does come up, it has its own tools, it has its own tool path, and there's a little bit of it that's a little different, so we'll cover that as just its own standalone. But if you have any questions, like always, just put it in the questions panel, either questions on this or anything else. But I'm just going to run through the thread mill tool path and a little bit on the tool side as well that might relate to thread milling. So let's take a look at the thread mill tool path. So you can find it in your ribbon, or you can go to the list as you see it here. And it is, like I said, it's its own tool path, only because it requires its own tool, and there's a little bit of extra stuff in the technology section that's a little different than, let's say, drilling. But ultimately, a lot of this is very similar to what you would see in the controls for profile and drilling. To start, the geometry is like you're choosing a drill. This window is the same as the drill geometry window. You're choosing a point or a circle or the wall of a cylinder, and you're getting that central data point there, that central drill point. And that's because if we're doing thread milling, we're essentially just telling it to do a helical tool path. It has its certain pitch, it has its certain TPI, but essentially if you look at it, it's really just some sort of a helical tool path. So we're just giving it the center of that circle, whether it's an internal thread or an external thread. The tool, well, this is one of those unique tool paths where when you click add tool, it really only gives you the one type of tool that's available for it. So you can't really do any thread milling with anything else other than a thread mill. Kind of makes sense, but there are other tool paths that we've seen where you might be doing something like a drilling and you could choose a flat end mill, or you could choose a lollipop or something. So sometimes the tool path doesn't automatically restrict you to a type of tool. Whereas this one is one of those unique ones where you're doing thread milling, you could only choose a thread mill. You have the two types, you have your standard and your taper, but you're really just doing the same thing. You're just defining the tool. So if I just click one of these quick,
And Mark,
you can see that.
before we get too deep here, when is a scenario where I would want to use a tapered thread mill?
I think that's a TPI, or not a TPI, NPT, right? Isn't that?
Yep, exactly.
Yeah.
So just want to, for everybody that doesn't know, the tapered ones are for the national pipe taps, or the BSP, which is British pipe tap, as well as the straight threads are for all your straight threads. So.
Yeah. I think normally you'll find it in the piping industry where they have that taper thread just because of the unique way that those things have to affix to each other. But yeah, it's British pipe thread and national pipe thread. National pipe thread is basically North American. So when you define that type of tool, whether it is the taper one like we're just talking about or this one here, you're basically choosing let me just turn that off there. You're basically choosing your dimensions like you normally would with all our other tools. More uniquely for the thread mill though is you're adding where is it on here? Number of teeth. There's thread cutting length, so that's kind of like the cutting length of your end mill. Oh, here it is, number of teeth. So as we know with thread mills, it could just be a single point tooth thread mill, or it could be one that has multiple teeth. When you define the multiple teeth, that actually feeds into the toolpath itself. So when you give it the thread length in your level section, it'll actually calculate how much of a toolpath to calculate based off the teeth. So that's one of those important parameters here. And then obviously cutting length and all that kind of stuff. But more importantly, this is very similar. You'll see a lot of similarities between this toolpath and some of our other ones. So one similarity here would be when you define a tap for your drilling cycle, same thing you do here. You choose from the table what type of tap you're creating. So there's our BSP, there's our UN, all the other ones in here. Let's just grab one of these real quick, because I know this table has both here, and you choose your thread. So again, this is not going to generate the thread in the toolpath. This is just defining the tool with the proper pitch. You're telling it how many teeth you have, the cutting length, it'll define the proper pitch for that tool. So if you just scroll through here, and in the UN table, you can see you got your standard, and then you got your fine. So just like when you define your tap. Otherwise, you could type, or you could click on user, and then you type in your proper pitch or TPI as you like. But that, again, is just very similar to when you define a tap. When you choose user, I think you actually even get an expanded list here, but you still have to type in your own parameters for your tool. But once you define your tool, let me just, yeah, I'm not going to say that because I have some other ones I want to show you. Levels, under levels, it's, again, very similar to what we've seen with other toolpaths. You have an upper level, lower level. In this case, you basically have an upper level and a thread depth, or you can define it by number of threads. So again, the number of teeth on the tool will inform how much of a movement of the tool makes to make these number of threads. And then technology section is where we find the main parameters of the toolpath. And this window, you can kind of consider this window to be a mix of what you would see with your drilling toolpath and what you would see with your profile toolpath. Because if you look over here, sorting, if we had multiple drill points, we could sort them by shortest distance, the default, which is the order that we selected them in, and advanced, like we see in the drilling toolpath, we get these patterns here. But everything else is more like a profile. So you have the ability to add a roughing pass with a wall offset, a clear offset. If you're doing just finishing, you could tell a number of passes. It's really just this lower section that's very unique to the thread milling toolpath. So either it's an internal or an external. It's a right hand or a left hand. You can tell it to go from the top to the bottom or bottom to the top. And then start angle. Start angle is going to be relative to where it starts. So for instance, if we take a look at some of these toolpaths that I already have created, one of those is my 0 degree start point. So I would just use that as the point of reference when I generate the toolpath and say, no, I don't want it to start there. I actually wanted to start maybe over here. I would just give it a start angle of 90 degrees or negative 90 degrees, whatever it needs to get to shift. Actually, let's just open this guy up so we can take a look at how this guy was programmed. So this was an internal toolpath. However this thread was defined, it has a major thread diameter of 64 millimeters, because I think this is one of the default parts that comes with your software. So this is one that is pre-programmed for you. You could take a look at, and it's in metric. So that's 64 millimeters in diameter, major diameter for that internal thread. It's a right-handed thread, and we're going from the top to bottom. So because it's right hand and it's internal, that actually comes out as conventional cut, conventional milling. So this is, again, very similar to what we talked about when we did negative X turning. You give it the tool definition, you give it, in this case, you give it tool definition, you give it the right hand or left hand, you give it internal or external, and then from the combinations of those, it'll tell you in the bottom right corner there what type of cutting you're doing, climb or conventional. Now, that is purely thread milling, and one thing that was actually added in the new versions of SolidCAM, if I remember this correctly, Kevin will back me up, is when you go to drilling, obviously you're going to pre-drill your thread mill. So you can actually do a drilling operation, you could do all the pre-drill hole and all that, and then in order to do the save and copy, you do save and copy, and then you can come up here and switch it directly to thread milling. So you can save that geometry, save those levels, a lot of the stuff you do when you do save and copy, but in the save and copy, the copy of it, you can switch it directly to thread milling. And then it just flips it to a thread milling toolpath, saving your geometry, saving your levels, and all you have to do is just insert your thread mill tool, your thread mill parameters.
Yeah, and this is a new feature that they added with 2020, and more or less along lines of like when you're doing spot drill, drill, tap, it's all in one operation, and you can just keep making copies. Well, before we couldn't do that because the thread milling was a complete different operation, so we couldn't make a copy. So now, like what Mark just showed us, we're able to retain the levels, we're able to retain the location, everything due to that threaded hole, and still not have to go back and redefine the geometry or pick it from the drop-down list. So just small little things to help you guys out.
Yeah, streamline your programming, reduce the number of clicks, that sort of thing. So that is basically thread milling as a toolpath. Well, one additional little cosmetic change you can make is what we've done with this part file. One of these is an internal, one of these is an external, and actually I think this external is a good example of it. This one was defined with maybe like 3 or 4 teeth, I can't remember, but you can see that the toolpath itself is only maybe like 3 passes. And that is, again, because the number of teeth that are defined on that tool means that with each one of those passes, it's actually generating all of those threads. And we can actually see that with the type of tool that was defined here. I'm just going to go to my tool table. And you can see with tools 1 and 3 that are in use, they actually have that little symbol next to them. And I think we've covered this before in SolidCAM Live. We've definitely covered this in KevCam and the tips and tricks videos. Anytime you want to add a shape to your tool, you can do that with any one of our tool definitions. In this case, I did it with the thread milling tool so that I can get a tool that looks like an actual thread mill. Now, this is not required. You can generate a thread milling tool path with just the default shape. The default shape actually looks just like that. And that's only because you're just defining a cutting surface, a cutting length. The number of teeth in use and all that are still defined. Your toolpath still comes out with the proper definitions, proper step downs, the proper thread. Remember I said before about the number of teeth. It'll still recognize how it should step down to generate all those threads. But this representation here will actually generate in your Solid Verify what it would look like an overcut. It would look like a gouge, only because it has this cylindrical shape. So if you want to see what the thread might actually look like cosmetically, then you can add the shape tool. And this will actually do the helical movement. It'll still generate a toolpath. And on your Solid Verify, you'll see what looks like threads. They might not necessarily match exactly what you've modeled in your SolidWorks model. In fact, I would actually even say you don't want to have this sort of cosmetic thread here, this actual physical representation of the thread, because that's going to disrupt your Solid Verify. It might look like it's some sort of a gouge when really it's not. Especially in turning, I would definitely say you don't want to see that, because remember, in turning, when you generate your target profile, it does that cross section, it does that revolve. You're going to get some weird geometry over here that is trying to approximate what that surface would look like. If you're doing a turning thread, this is not thread milling, but this is just kind of threading and turning, have it as just that cylindrical representation. Even maybe just go as so far as when you get your design model from your design department, suppress whatever cosmetic stuff they put there, and then that way you get that nice cylindrical face, and then you have a nice straight line for your thread milling toolpath. And then you can do Solid Verify, and then you can see your thread. But from the design model side of things, keep the geometry simple. Don't have this cosmetic thread. When you're doing thread milling, it's the same sort of thing. You're really just generating a thread milling toolpath off of a center point. So this thread is not helping you. It's not a help. It's not really a hindrance either. But I think because you're defining your target off of this model, it's going to think that you've cross-threaded your part. It's going to give you some gouge check issues. And really, that's not what's going on. So I would say this is going to be confusing on the simulation side. I would just get it to be a simple cylinder. But let's take a look at how those work in the Solid Verify. So as you can see there, my stock is just representative as a cylinder there. I'll run the first one with my shape tool. You can see that it generates what looks like threads. And you can see that it is a helical movement because it starts that thread off there. And then for the external, something like that. So you can see that it does generate a thread. It even goes so far as giving me that little bit over there. But what I was mentioning before, my target actually looks like it has the thread, but they're not even in the same spot. So you get that weird cross threading. And it actually would look like a gouge. But if you want to see the thread generated by your thread mill, you want to just kind of make it look like it's some sort of cosmetic, then that's the way. Add a shape to your thread mill, and then you can get what would look like your realistic toolpath. So any questions on that?
Looking good.
Like I said, a lot of people don't use thread mill. I know we didn't do it a lot because those things are expensive. So we really only saved it for really hard materials when we really couldn't use whatever standard taps we have, or if it was basically an external thread like this thing. If we couldn't turn it because of reach issues or something like that, we would put it on the mill, and then they would trust me as the young programmer with this thread mill, and I put really conservative feed rates on that, just to kind of give the operator a chance to hit the button just in case he was going too far. And yeah, we bought two because I broke the first one. But yeah, So regardless of what type of thread mill you get, you should be able to define whatever shape it is, even if you're not doing the actual shape using our shape options. If you're just defining it straight up as number of teeth and all that, whatever type of thread mill you have, you should be able to define it with our thread mill definition. Not much else to talk about thread mill. I think that's I think I covered everything related to that. Don't want to make too short of a class today, but really this is all I had to talk about today. What do you think, Kevin? You got anything, any questions or anything that's come up during the week that we could finish up on a Friday?
No, I really don't. Just trying to think offhand, but sorry guys. Between Mark and myself and all the other tech guys, about Friday is when our brains start turning into mush.
I think that's the same for all of us. So actually, talking about tools, we'll do a little bit of a plug. So Tuesday of next week is the major, hey, what's new in the tool table in 2021, right, Kevin?
Yep, we're going to do a sneak peek at the new tool library for everyone, as well as some new features in SolidCAM 2021. So definitely, if you guys aren't signed up for that, take advantage of that and check it out. And maybe, Mark, if you could pull up your internet and just show people where they go to register for that, because I know that does come up every once in a while.
Okay, so we go to the SolidCAM website, and I believe this is probably still a thing. You have to make sure that you have the American flag up here.
Yep.
Okay. I'm not sure why Canada is considered the British flag, but we'll talk to the site administrators about that.
Even the United States on my end, I get the British flag, so don't worry.
But yeah, so make sure you're signed in on the US geolocated version of the website, and then we go to webinars, right?
Yep, and CAD
upcoming.
Or you can come to the upcoming ones, or you guys can come right to the CAD one as well.
Oh, CAD Night School, he's got his own thing right there, and there it is. So click on that guy. So that's the 21st. That is Tuesday next week. Does it say what time?
It is going to be at 8 o'clock Central Time, 9 p.m. Eastern.
There it is. And then you click on that, sign up, and then you'll get the link. And then on that day, at that time, it's just like this session here. You log in, and then you guys can ask questions live.
Yep.
Kevin, Greg, and whatever special guest sales guy is there.
Yep, Sid will be there on this one as well.
Wow, okay, Sid will be there too. So you guys will be able to ask questions live about the new tool library to the SolidCAM professor.
Not just the, what do they have written in here? Not just the doctor professor, which is definitely false advertising, but.
Yeah, doctor professor. Do they even have it on here? Yeah, CAM Doctor Professor Kevin Rankle, CWSE. They should give you more letters there.
Yeah.
You got more. Yep. I'm usually asleep by that time, so that's why I'm not attending. I'm an old man now.
But yeah, definitely guys, come check it out.
Tune in for that. Yeah.
There'll be some cool stuff that's going to be showed off there. So.
Yep. Okay, so I guess that's it. So yeah, tune in for that next week. That's actually a major addition we're going to be doing to the new version of the software. So you definitely want to check that out. Just see if there's any questions or anything that's popped up in the chat. Oh, okay, you're right ahead of time. So Kevin just put my email in the chat section. So please use that if you have any questions, comments, suggestions for the class, anything you'd like to see, any parts you have. If you'd like to have your own personalized training session, you can use that email as well to contact me directly with the day and time that you're free. What we do is we get into a GoToMeeting. We use the mic and speakers of your computer or the phone, and you can ask questions live while you're on the GoToMeeting with me. If you know anybody that can benefit from SolidCAM, give them our contact info or get them to contact us. And if they get into a demo, then you get that $100 gift card. If they go to sale, you get 20% of that sale. And all you got to do is just get them in contact with us. And we basically just consider that to be a finder's fee. You're helping us out, so we give you some money just to give that kind of incentive there. We will be continuing this until the end of the month currently. If the attendance keeps up, we'll see what happens after that. But for now, we'll be doing this every day until the end of the month at 2 p.m. Eastern time. So I'll see you guys on Monday. Stay safe, keep your family safe, keep busy. We will talk to you on Monday.
All right. Have a great weekend, everyone.